Hello friends, a very warm welcome to all the viewers of wisdomjobs.com. In this video, I am going to explain you the different properties of metals and non-metals. So please be tuned to our channel wisdomjobs.com for more videos, because we are going to give you so many important videos in the exam point of view so that you could not miss. So if you have not yet registered with our or subscribed with our wisdomjobs.com, please do subscribe and get more and more videos and information. If you have got any queries regarding our videos, please do express those queries or doubts in the comment box provided at the bottom of the video, so that as and when we find time for you, we are going to answer your queries. Now let me start with the class. So in this class, I am going to explain you about the concept of metals and non-metals. Okay, now the different elements in the periodic table can be broadly classified into metals and non-metals, and generally the set of metals have got different properties, like lustrousness means shining, next hardness, next malleability, ductility, high conductivity, reactivity, etc. Okay, now let me explain you each of this property in detail. Now if you take metals like copper or gold, or let me say zinc or iron, etc., they have got a clear-cut shining on them. Okay, so they are shining. So this shining is also called as lustrous property. Okay, so they are shining or lustrous. Okay, and over a period of time, so actually in their native state, in the original state, they will be shining, but due to reaction with some of the oxygen or say any other non-metals, they form their respective oxides or other compounds, and they might lose their shining or they might lose their perfect color. Yeah, one more aspect is that many of the metals are color. Okay, so if you take silver, it is white in color. If you take gold, it is yellow. Okay, next if you take copper is red. Okay, and of course sometimes pig iron also is red in color. Okay, so different elements or different metals have got different colorations. Okay, so first of all, they are lustrous and colorful. Second property is their malleability and ductility. Now if you observe, some of the metals can be made into sheets. Okay, by beating them at higher temperatures, a block of a metal can be made into a sheet, or it can be converted into a sheet. So the conversion of sheet property of a metal into a sheet is called malleability. Okay, so any metal can be changed into a sheet, or it can be converted into a metal sheet, and this property of a metal, in order to convert it into a sheet, is called malleability. And any metal can be converted into wires. Okay, and thin wires, that too, very thin wires. So this will be called as ductility. So what is meant by ductility? Ductility of a metal is that property of it by virtue of which a metal can be made into wires or thin wires. Okay, now if you take copper, the best example I can give you is in our day-to-day life is our electric wires, which are carrying the currents. Okay, so steel inside it or copper inside it is in the form of a wire or cylindrical wire. So copper. Next, if you take our gold chains, all our ornaments in the form of gold chains or platinum chains, they are basically they are converted first into wires, and then they are twined into a big chain. Okay, so 3 or 4 gold chains or gold wires are twined into a chain, and that chain we are wearing, is it not? So of course, if you take ring also, first of all, basically ring is converted into, it is a basic, the basically structure of a ring is nothing but a wire. The wire is made into a ring, so that structure is that the structurable wire is called, that property is called as ductility. And if you observe in our day-to-day life, the metals like copper, silver, gold, okay, these are some of the these are some of the metals which are converted into wires, and they are ductile in nature. Okay, next property, high melting and boiling points. Okay, now if you take iron, okay, iron it will be converted into a liquid, or iron melts only at a temperature of around 1200 degrees centigrade or around 1300 degrees centigrade. Okay, now if you take a normal oxygen or hydrogen, which are in the form of gases, by simple temperature rise, they will be melting. So the melting points of non-metals are very low, but compared to the metals, so if I mean, I don't exactly know the exact values of melting points. Take for example copper or zinc. Okay, of course zinc has got lesser melting point. So copper or iron or aluminium. So these are all some of the metals where we need to raise their temperature to a very higher value so as to make them melt. So from this, what can I say is the melting point of metals is very high. Similarly, the boiling point of these metals is still more higher when compared to the melting points. Okay, so they have got very high and melting points and boiling points. Next, let me give you a test how to explain the conductivity of a metal. Take a stand, okay, and take a screw like structure here. Okay, this is a stand actually. Okay, this is a stand and this is a screw. Okay, to this screw just insert a metal rod, and on the other side you just coat it with a wax. So this is wax coating, and here you will be having a burner. So take a burner, start heating. Okay, so this is the flame for you, this is the burner, start heating. Okay, now if it is not conducting, if it is not a good conductor of heat, what's happening? This won't get heated and the wax will be as it is. But what happens as the flame continues to supply the heat energy to this conductor or to this metal rod? So this is your metal rod actually. So for this metal rod, as the heat is provided, slowly it gets heated up and the wax started melting. Okay, the wax slowly starts melting. So what does it indicate? If the wax is not melting, then it is a bad conductor, but the wax is getting melted and you can see the droplets here. Okay, so the wax droplets will be slowly falling down. Okay, so what does it indicate? It indicates that the metallic rod is getting heated up and it is a good conductor of heat. So by this experiment, what can I conclude? All the metals are good conductors of heat. Okay, next let me take one more example or one more experiment actually. So let us take a circuit diagram now. So take a bulb. Okay, so this is let me say this is a bulb connected in a circuit like this. Okay, and the other end of it is given to a supply. So these terminals are supply terminals, and here you have got the other end of the supply terminals you are going to give to a conductor. Okay, one end of it is given to your, okay, so the other end of the conductor is given to the bulb. So now this is your bulb. Now when the current starts flowing, okay, if it is not a good conductor, the current enters up to this point and it stops. Okay, and there won't be flow of current. So when there is no flow of current, then the bulb won't glow. But when the supply is given, the bulb starts glowing. So what does it indicate? When the bulb starts glowing, it indicates that the the metal also starts conducting electricity. That means the metallic wire or piece here it is allowing the electricity or the current to flow through it. So I can say that it is a good conductor. So all metals are good conductors and also good conductors of electricity and heat both. So they conduct heat and they conduct electricity. So what are the different properties? They are malleable, they are ductile, and they are highly reactive, they are lustrous, okay, they are strong and hard, and finally they are good conductors. Okay, now let me come to the next topic of reactivity. Reactivity will be in two types actually. Reactivity would be between water, oxygen and other compounds. Okay, now let us come to oxygen. Take a magnesium ribbon and slowly start heating it or supply heat energy to it. What's going to happen? A white powder is being formed. That white powder would be what actually? It is the formation of magnesium oxide. Magnesium oxide. Now, sodium is a very smooth metal which is generally kept under kerosene. Okay, so always sodium is placed under kerosene because it is so reactive, it is highly reactive, it is so highly reactive that it will immediately, as and when it comes out of the kerosene, it starts immediately reacting with oxygen and it forms the sodium oxide. Okay, so sodium and potassium, they are very highly reactive and they readily form their respective oxides, whether either sodium oxide or potassium oxide. Similarly, if you take metals like magnesium should be applied with heat. So they are not so ready. Magnesium is not so ready to react with our oxygen. Okay, so slowly we need to it need to be heated, the magnesium ribbon heated, and then it will form the oxide of magnesium, that is magnesium oxide. Similarly, calcium. So take a piece of calcium and heat it, then you will be forming the calcium oxide. Okay, so some metals are very highly reactive like sodium and potassium with oxygen, and some are not so readily reactive but they react with oxygen and they will be forming their respective oxides. Now if you take iron or aluminium, so what happens when aluminium is placed in free space or in air? What happens is the air in aluminium, okay, the air in aluminium will be forming aluminium oxide. Okay, so aluminium oxide is a powdery substance and it will form initially a coat over the aluminium metal. Okay, and the so formed aluminium oxide coat, it will not allow the further oxidation of aluminium and it prevents the original first formed coat will prevent further oxidation of aluminium. Okay, so if you take aluminium or zinc or copper, so if you take copper also, yeah, so it will give you 2CuO. Okay, so copper oxide also is slightly black in coloration, and that copper oxide layer will be formed on the original pure copper metal, and further oxidation will not be possible. So they are not highly reactive, they are reactive to oxygen. But coming to sodium and potassium, they are readily reactive and it will produce heat energy also due to the reaction. Okay, and coming to the other oxides, they are slightly reactive. So there is an order in which the metals will react with oxygen, and as you come to zinc is the least, and of course if you take gold is not at all reactive with oxygen. So if you take gold, it is least reactive, and if you take sodium, it is highly reactive, sodium or potassium. Okay, next coming to water. So water, if you observe the reaction of these metals with water, how it will be is, if you take sodium and if it reacts with water, okay, so what's happening is I can say 2Na plus 2H2O will give rise to 2NaOH plus H2. Okay, now the reaction is so dangerous, or it is so fast that the heat energy released in this reaction will wash away, or it will heat away the hydrogen, or the hydrogen gas also accepts the heat energy and there will be flames possible. So the reaction is so fast that it is giving flames also sometimes. So you need to be very much controlled while dealing with sodium. So sodium is very dangerous and highly reactive metal. That's what I mean to say. So sodium is so reactive to water that it readily forms sodium hydroxide. Similarly potassium. So the same reaction will hold good for potassium. So 2KOH plus H2. So the hydrogen liberated readily catches the fire from the exothermic reaction. Because this is an exothermic reaction, the hydrogen catches fire and we need to take care of this, how to control the fire. Okay. Next, if you take some other metals like magnesium. Okay. So what happens to magnesium is, magnesium is not that much ready, but we need to heat water. That means it will react with hot water. So Mg plus 2H2O gives rise to MgOH twice plus H2. Same is the case here. Okay. So magnesium hydroxide plus H2. Okay. So here also what happens? The magnesium metal reacts with not cold water, as in the case of potassium or sodium. So if sodium and potassium, they readily react with even cold water also, but magnesium or calcium, they react with hot water. Okay. And of course copper also. And if you take iron or other metals, they slightly react with steam. Okay. So other metals other than these four which I told, magnesium, calcium, potassium and sodium, other than this, they react with steam to form their respective hydroxides. Okay. And if you take elements like gold, whatever form of water you take, whether it is steam or whether it is hot water or cold water, they don't react with, the gold don't react with water. So this is the, of course, this property of gold makes us to do the ornaments. Okay. So we go for gold only for ornaments because it doesn't react with water, due to which our women in the house, they can easily work with water. Next, let us talk about the other metal displacements. Now the high reactive metals displace low reactive metals, from their compounds. For example, let us take sodium or potassium, let us take, and zinc sulfate. Okay. So what happens? The zinc from zinc sulfate will be liberated by potassium. Why? Because potassium is highly reactive and zinc is not that much reactive. So from ZnSO4, zinc is displaced by potassium, forming K2SO4, which is potassium sulfate plus zinc. Okay. So we have got a reactivity table. So based on that reactivity table, we can easily understand which element can replace or which element can displace the other element. Okay. So first, in the table provided, we have got a table actually starting from potassium. So potassium is the most reactive element and followed by zinc. That means zinc is the least reactive element and potassium is the most reactive element. So I'll give you the list of the priority list of the reactive elements. Okay. So you can make a note of those list. Okay. So this is the reactivity table. So starting from potassium, the next most reactive element is sodium. After that, calcium, magnesium, so on and so forth. So the least reactive element is gold. Okay. So the most reactive element is potassium and the least reactive element is gold. So in this order, for example, if I have got magnesium and aluminum compounds, so magnesium is more reactive than aluminum, so magnesium displaces aluminum. Other example if I give, if calcium and zinc compounds are reacting, so calcium displaces zinc from zinc compound and calcium compound is formed. So in this way, one element can reach, one metal will replace the other metal in this order. Okay, so this is the order of reactivity. Now in the next class, in the next video, I will be dealing about the properties of non-metals and the extraction of these metals. Okay, that is metallurgy. So that means what is calcination, what is roasting, etc., etc. I will deal in the next video while we are dealing with the extraction of metals concept. Okay, so I think you have got good idea of what are the properties of metals. Okay, so if you have got any queries in this topic, please do express your doubts or queries in the comment, and as and when we find time, we are going to revert back to you. Thank you for watching.